So, hi everyone. Today we are going to see what is quantum mechanics, because in this lecture I will teach you what is quantum mechanics, and basically I want to update you that this lecture will be for beginners. So let's get started, right? In our daily life we see the objects, like how they behave. When I talk about any particle, suppose let me just take this particle, right? If it is this particle and I throw it toward the wall, suppose if I throw this particle toward this board, so this particle will strike and will fall down, right? If I do this experiment 100 times, then the result will be same. The result will be, if I throw this particle 100 times, then it will strike with this and it will get fall, right? It will get fallen. Now, what happens when we study quantum mechanics? Basically, it is the behavior of particles at atomic level. When we go to the atomic level, the physics which we see around us, like classical physics, it can't explain the behavior of atomic particle, right? Now, when we talk about quantum mechanics, so when we throw subatomic particles toward a wall, then it strikes with that wall, and there are probabilities that it can go through that wall. But in the reality, as we see at the macroscopic level, not micro, at the macroscopic level, particle do not go across this wall, right? But at the atomic level, there are probabilities that the particle may pass through that wall or may not pass through that wall. This probability will be dependent on the wave function which we'll use in the quantum mechanics. So basically, quantum mechanics will tell you that how the particle at atomic level behaves, right? Now, what happens when we say, like, here I have this stuff, right? If I just hold this stuff, so I can clearly see that this is a particle which has certain mass. It can't be a wave. What is wave? When we talk about wave, it is a pattern or disturbance, right? So when we talk about wave, like my sound is coming to you, it is the form of wave, and wave is propagated through particle and sometimes through not particle. Light, we can take example of light, electromagnetic radiation. Electromagnetic radiation do not require any kind of medium. It travels in the form of wave like this, right? And the specific behavior of wave and particle can be distinguished when we do double slit experiment. Okay, just forget about this right now. Let's think about one situation. What happens when water pass through a hole of opening of your door? That water will come into your room and will spread out into the room, right? So it is the nature of wave. Let me just give you an example. Suppose this is a door and there is a small opening in that. So if water will come through that hole, then water will get passed through that hole and will spread into the room like this, right? It may go through this, it may go through this path, it may go through this path, it may go through this path. It can spread. What? When we talk about a particle. So when I take a particle, there is small opening again. Now, for the particle behavior, if I just think like this is a solid stuff, like a stone, if I pass or if I throw that stone through this opening, then this will go in the straight path, right? So this is the basic difference between being a particle and being a wave. Wave can spread throughout the room, but particle cannot spread. It goes in a straight line. Is it right? Right. So this happens when we see the nature in classical physics. In reality world, what is meant by reality world? It is classical physics in which we live. We observe the things. But when we talk about the atomic level, the particle do not behave as usual we see in reality, in classical physics. Because in classical physics, an electron, like you can see here, an electron, if that electron passes through some opening or some slit, it may get dispersed into the room, or it may get spread, right? When I talk about a particle must go through a single opening and it must hit a wall on the one point. But when we think about this particle at atomic level, it spreads in the room. So here I can clearly say that electron or particle is behaving as a wave, right? And in the quantum physics or at quantum level, the light or radiation may behave as a particle. This is what we see in photoelectric effect. In the photoelectric effect, Einstein beautifully explained in 1905 by his thesis, and it was like light or radiation was behaving as a particle. Now again, in quantum mechanics, when we see the things, electron or particle can behave as a wave and wave can behave as a particle. So this is the basic thing in the quantum mechanics which can differ, which differs our reality from classical to quantum mechanics. Again, there is a big catch in this quantum mechanics, and that catch is very different. In reality, when we study about special theory of relativity, it simply tells, if you see a light or anything other than light, that thing cannot move faster than the speed of light, right? Again, what I say in special relativity, that nothing can move faster than speed of light. But when we talk about quantum mechanics, when we will see in detail, because this is the beginning, this is the intro part where I just want to force you to understand that quantum mechanics is totally different from classical physics, because there are some problem in the classical physics which could not be explained simply, so we used quantum mechanics. There are many more problems, but today I just want to discuss you simple things, right? Now, nothing can move faster than the speed of light. This is the main quote of the relativity, where the speed of light is extremum, right? Now, when we think about quantum mechanics, there are certain particles in pair which have certain kind of information. What kind of information? No one knows, but we will see that what it could be, right? So when we talk about two particles, they are entangled. Entangled means they are connected. They are connected by some kind of information, and that information travels faster than speed of light. But you may take care one thing, and that is, it could be some kind of a tricky part, because in Bell's inequality, or we can say the Einstein's part which he said like spooky action at a distance, it is totally different in quantum mechanics, and we will see in detail what was that part and discussion. So when I say that two particles are connected with some kind of information, and that information travels faster than the speed of light, then they are entangled with each other. For example, suppose a particle is resting in a galaxy, particle A, and particle B somewhere here in another galaxy, and galaxy is too much far, right? Where the light light may take up to billions of years to reach from one part to another part. But when we talk about the entangled particle, so their information is transferred immediately at instant. So it is the instant phenomena in quantum entanglement where information travels faster than the speed of light. It is totally different because it directly challenges the Einstein's quote of nothing can move faster than the speed of light. So quantum mechanics basically explains many more phenomena at atomic level, but there are certain more things. So we will discuss everything in detail. Now I can say, and I can think that now you have got the idea why we need quantum mechanics. Basically in the next part we will see more things in detail, right? It was the intro part. So thank you. All my life holding all of it closely, I played it innocent, a feel of discontent, I'm finally facing it all, fearless.